everyone. Today our lesson is functions of two or more independent variables, limits of two variable functions. So, multivariable functions. Definition: functions of n independent variables. Suppose D is a set of n tuples of real numbers of these real numbers. A real valued function of D on D is a rule that assigns a unique real numbers W equal to f of x1, x2, and etc. xn to each element in D. The set D is a function's domain. The set of W values taken on by f is a function's range. The sample W is the dependent variable of f, and f is said to be a function of the n independent variables x1 to xn. We also call the xj's the function's input variables, and call w the function's output variables. Interior and boundary points, open and closed region. Definition: interior and boundary points, open and closed. A point x0 and y0 in a region R in the xy plane is an interior point of R if it's the center of a disk of positive radius that lies entirely in R. A point x0 and y0 is a boundary point of R if every disk centered at x0 and y0 contains points that lie outside of R, as well as points that lie in R. The interior points of a region as a set make up the interior of the region. The region's boundary points make up its boundary. A region is open if it consists entirely of interior points. A region is closed if it contains all its boundary points. Limits of multivariable functions. We say that a function f of xy approaches the limit L as x and y approaches x0 and y0, and you write in this form. If for every number epsilon greater than 0, there exists a corresponding number delta greater than 0, such that for all x and y in the domain of f, module f of x y minus L less than epsilon whenever this inequality is satisfied. Okay, limits along smooth curves. The following rules hold if L, M, and the car are real numbers, and here first limit is L and the second limit is M. Let's see some examples to limits of multivariable functions. So first example, limit xy approaches to 0, 1, and the version x minus xy plus 3 x squared y plus 5 xy minus even cubed. So here we put 0 instead of x and 1 instead of y. And 3 over minus 1, and we get the solution minus 3. So our first solution is minus 3. Let's see the second example. The limit xy approaches 3 minus 4, and the function x squared plus y squared. So here the same, we put the 3 instead of x and minus 4 instead of y. And we get the solution 5. Let's see the next one. Here we will find the limit of the function f where x and y approaches to 0, 0. So the limit cannot be found by direct substitution, which gives the form 0 over 0. We examine the value of f along curves that end at 0, 0. Along the curve y equal to x squared, where x naught is equal to 0, the function has a constant value. Here, instead of y, we put the x squared, and we will get the expression, this expression, 2 over 1 plus squared, and this limit varies with the type of approach. If x and y approaches 0, 0 along the parabola y equal to x squared, for instance, equal to 1, and the limit is 1. If x and y approaches 0, 0 along the x-axis, equal to 0, and the limit is 0. By the two-pass test, f has no limit as xy approaches to 0, 0. Let's see another example like the last one. So here we get y, x, and here we get the solution 0.